All right, so question number 6. It gives us the graph of f of x. It says x to the fifth minus 2x to the fourth plus 2x cubed minus x squared minus x plus 1. It says use the graph and your understanding of the concepts associated with the fundamental theorem of algebra to determine how many rational, irrational, imaginary zeros. Hey, first of all, if this is x to the fifth power, that means it has to have 5 zeros. Now, it could have repeated zeros, or it could, with multiplicity 2 or higher. It could also have imaginary, which you can't see on the graph, but it's going to have 5 zeros. So the first thing, it says f has blank rationals. Well, to determine that, I'm going to make my list. So my last number is 1, so plus or minus 1 over, and my first number is 1. Well, that means I only have 2 possible rational zeros, 1 and negative 1. Well, take a look at the graph. That is not negative 1, but that one is positive 1. So 1 is my rational zero. Now, it's going to be multiplicity 2. Because it bounces off, like it comes down and bounces. So down here, like the function has how many rational zeros? Even though 1 is repeated twice because it bounces, we don't only count it once. So it has 1 rational zero. Now notice it's not the actual answer. It's not asking for what is the zero? It's asking how many. Now in this case, it's the same, right? My zero is 1 plus I have one rational zero. Okay, now it says how many irrational ones? Well, the graph crosses over here. If the graph crosses over here and it's not rational, right? It was not on my list up here. That's not 1 or negative 1. That means it can't be rational. It has to be irrational. So there is 1 irrational zero. So just think of that. There's 1 multiplicity 2. There's another 0, and it just crosses 1, so that's multiplicity 1. And then I have to have a total of 5. So this one counts as 2. This one I don't know. I don't know what it is yet. Right, that's a question mark. But I know it's multiplicity 1 because it just crosses. So I have 3 so far. It's x to the fifth. It has to be, so it has to be a total of 5. So that leaves me with 2 imaginary zeros. Now notice how I didn't even find on that one the irrational or the imaginary. I just knew what about the graph, right? If it crosses, then it has to be a real number, either rational or irrational. If it's not on my list of rational, then it's got to be irrational over here. And if I only have 3, like 1, and this one counts as 2, 3, that means my imaginary there has to be 2 imaginary on there also. Let's switch over to the actual problem. We'll put that in there, just double check our answer, make sure everything looks good. So we said it has 1 rational zero. We had 1 irrational zero, and we have 2 imaginary. And just remember, that only adds up to be 4 zeros, but that 1 rational, because it bounced, counts as 2 as I go across there. Check the answer, it looks good.